Okay, so we are on to day 7 of our Exponents and Logarithms unit, and we're looking at solving exponential equations today. And we've done a little bit of this, and we're coming back to it again, and we'll look at some new ways of solving exponential equations. So to begin, we're going to look at solving an exponential equation in 4 different ways. So let's take 2 to the power of x plus 1 is equal to 8 to the power of 2x, and we are looking to solve for x. So the first strategy we will use is to rewrite 2 and 8 as powers with a common base, and then go from there. So no need to do anything to the left-hand side. We've got 2 to the power of x plus 1. But on the right-hand side, we're going to rewrite 8 as 2 cubed. So we've got 2 cubed, and we are raising that to the power of 2x. Okay. So from here, we'll skip some steps here. We have powers with the same base, single powers with the same base on either side of the equation. So we can drop the base and we can evaluate the exponents. So we're going to be left with x plus 1 on the left-hand side. And then using power law, 3 times 2x, we get 6x. On the right-hand side, we get 1 is equal to 5x. And so x is equal to 1 over 5. Okay, and I'm going to, in brackets here, whoops, so that we have this fresh in our mind, 1 over 5 as a decimal is 0.2. We're going to see that in a few minutes. Okay, so there's strategy 1. That one we have used before. This one is new. We're going to take the base 10 log of both sides of the equation. Okay, so we've got 2 to the power of x plus 1 is equal to 8 to the power of 2x. Now I'm leaving some space here, and you'll see why in just a second. Now with equations, and we've been doing this since back in grade 9, where we start to learn how to solve basic equations. But with equations, if we do, we can manipulate equations by doing something to the equation, but we would have to do that something to each part of the equation. So oftentimes we might, let's say, divide every part of an equation by -1, or divide it by 2, or different things like that. So we're going to apply the same principle here, but we are going to log both sides of the equation. So I'm just going to write a log out in front of the 2 to the x plus 1, and I'm going to write a log out in front of the 8 to the 2x. Okay, so those 2 to the power of x plus 1 and 8 to the power of 2x, those become the arguments of our logarithm. Now from here we can use power law, so we can take those exponents out in front of the logarithms as coefficients. And I notice that on the left-hand side, our exponent contains 2 terms, x plus 1. So when I bring that out in front, I'm going to contain it within a set of brackets. I'm going to rewrite that as x plus 1 times the log of 2. And on the right-hand side, we have 2x times the log of 8. Okay, now coefficients are numbers that are being multiplied by something else, usually a variable. In this case, we're multiplying these coefficients by a logarithm. So as I expand x plus 1 times the log of 2 out, I'm going to get x times log 2 is x log 2. Sorry. And 1 times the log of 2 is just log 2. Okay, now from here we are looking to solve for x, so let's get all of the terms containing an x to one side of the equation, and let's get everything else to the other side of the equation. So my next step, I've got x log 2, and I'm going to move that term from right to left. It's going to become minus in the process. So minus 2x log 8 is equal to negative log 2. Okay, now the two terms on the left-hand side of the equation, they have an x in common. Let's factor that x out as a GCF. Factor that out, it leaves us with the log of 2 minus 2 times the log of 8. And this is equal to the negative log of 2. And from here, we can divide both sides of the equation by those two terms in brackets, and that allows us to isolate x. So we're going to divide by log 2 minus 2 log 8. And same thing over here. Divide by log 2 minus 2 log 8. So on the left-hand side, those cancel each other out. We're left with x. And on the right-hand side, we're left with the negative log of 2 divided by log 2 minus 2 log 8. And if you were to punch that into your calculator, what you would end up with is that x is equal to 0.2. Okay, so same solution, different process. Okay, or different approach. Here's a third approach. This is something else we can do. So we took the log of both sides. Now you don't see the base there, so we can assume that we took the base 10 log of both sides. We could take the base anything of both sides of the equation, and it will be helpful here to take the base 2 logarithm, and we'll see why in just a second. So step 3, take the not base 10 log of both sides and then use power law. So we're going to take the base 2 logarithm of both sides here. So here's what our equation will look like. We're going to have log base 2 of 2 to the power of x plus 1 is equal to log base 2 of 8 to the power of 2x. Okay, now again, we're going to use power law here, so we'll take those exponents out in front as coefficients. So we're going to have x plus 1 in brackets. So we've got x plus 1 times log base 2 of 2 is equal to 2x times log base 2 of 8. Okay, so let's think about a logarithm. A log is our base raised to some power gives us our argument. So if we're going to look at this first one here, look at this first one here. This is log base 2 of 2. So the base is 2 raised to what power is 2? 1. So log base 2 of 2 is 1. So we'll just say that that goes to 1. And then log base 2 of 8, 2 raised to what power gives us 8? That is 3. So this goes to 3. And so really what we end up with is x plus 1 times 1, so that we have x plus 1 on the left-hand side. And then 2x times 3, we have 6x on the right-hand side. And again, we end up with x being equal to 1 over 5. Okay, so 3 different strategies all producing the same result. And the last one, we won't actually do this, but it is possible. And if you've still got Desmos downloaded to your phone, or you happen to have a graphing calculator handy, just plug in the equation. So with Desmos, either side of the equation you will plug in individually. So it would be y is equal to 2 to the power of x plus 1. That's going to be one equation. And then a separate equation on a separate line, you would plug in y is equal to 8 to the power of 2x. And then you're just going to look for the intersection point of those two functions, and the x-coordinate of that intersection point is your solution for x. And what you'll find is that that intersection point happens where x is 0.2. So that would be 4 different strategies for solving that equation. Okay, so the next one here, if we were given this equation here, so 2 to the power of x plus 1 is equal to 7 to the power of 2x, which methods could you apply? So let's just look at our first, our second, our third, and our fourth different methods here. Okay, so the first method was to rewrite the bases with or rewrite the powers with a common base. So we're looking at 2 and 7. Is it possible to rewrite those powers with a common base? No, it's not. So method number 1 would not work for us to solve this equation. Okay, but the remaining 3 would work. With varying degrees of difficulty, we could take the base 10 logarithm of both sides and solve this. We could take strategy number 3, we could take the base anything logarithm of both sides, so that would work. And we could also graph this and find the x-coordinate of the intersection points. Okay, moving along here. So in summary, if possible, convert both powers or both sides of the equation to the same base and solve. Otherwise, log both sides of the equation and solve using our log laws. Okay, so let's take a look at our first example here. 3 to the power of x is equal to 20. First thing I'm thinking about is, can I rewrite 3 and 20 as powers with the same base? No, I cannot. So let's move on to the next strategy, which is to just log both sides. So I'm going to rewrite this as the log of 3 to the x is equal to the log of 20. I'm going to use power law. We'll move that x out in front. We get x times the log of 3 is equal to the log of 20. And from here, we'll divide both sides by the log of 3. And so we get that x is equal to the log of 20 divided by the log of 3. And it's asking us to provide a solution to 4 decimal places. So if we plug this into our calculator, what would we get? I'll let you figure that out. If we leave it as the log of 20 divided by the log of 3, that is an exact value, but you can just directly plug that into your calculator, log 20 divided by log 3, and you'll get a decimal answer. Okay, next one, number 2. So same type of idea. I'm going to take this one step further and simplify before we start to solve this. I'm going to divide both sides of the equation by 120. So on the left-hand side, the 120s cancel each other out. So we're left with 1.12 to the power of n. And on the right-hand side, we're left with 40. Okay, now we can't convert 1.12 and 40 to powers with the same base. So we're going to log both sides. So we'll rewrite this as the log of 1.12 to the n is equal to the log of 40. We'll bring the n out in front. N times the log of 1.12 is equal to the log of 40. And we'll divide both sides by the log of 1.12. So we get that n is equal to the log of 40 divided by the log of 1.12. And again, you would just directly plug that into your calculator. Log 40 divided by log 1.12. Okay, and the next one, same idea, just increasing the degree of difficulty a little bit. I'm going to log both sides to begin. So we're going to rewrite this as the log of 2 to the 3x minus 5 is equal to the log of 35. Now, power law tells us that we can take that exponent, we can move it out in front of the logarithm as a coefficient. Two terms in that exponent, so I'm going to make sure when I do bring this out in front that I contain both of those terms in brackets so that I know that they are both the coefficient of the log of 2, meaning we're multiplying both terms by the log of 2. And so here's our next step. From here we will expand the brackets. So 3x times the log of 2 is 3x log 2. And negative 5 times the log of 2 is negative 5 log 2. This is equal to the log of 35. Now, isolate x. So we'll keep the term with the x on one side. We'll move everything else to the other side. We've got 3x log 2 is equal to the log of 35 plus 5 times the log of 2. And from here we can divide both sides by 3 log 2. That's going to isolate x on the left. And what does that leave us with on the right? We can just leave it as is. That's an exact value. So x is equal to the log of 35 plus 5 times the log of 2, all divided by 3 times the log of 2. Okay, leave it like that as an exact value, or you can plug that into your calculator. Okay, just a couple more here. Now, one of the things that you may be inclined to do here in your first step is to try to divide this. Okay, but we cannot do that. Okay, we can't take a power such as 12 to the power of x plus 1 and divide it by 2. Now, if 12 had its own coefficient, let's say it was 4 times 12 to the power of x plus 1. Now, sure, we can divide that by 2, but that's not the case here. So what we're doing is we are logging both sides, and I'll just try to be very explicit here about what's happening on the left-hand side. So on the left-hand side, we have the log of, now our argument is 2 times 6 to the x. Okay, on the left-hand side, right-hand side, we have the log of 12 to the power of x plus 1. Now, On the left-hand side, our argument is the product of 2 and 6 to the x. So multiplication law tells us that we can rewrite this as the sum of two logarithms. So we're going to rewrite the left as the log of 2 plus the log of 6 to the x. Okay, and then on the right-hand side, we're not going to do anything with this yet. Okay, next step though, we can use power law. So take each of the exponents and move them out in front of the logarithms as coefficients. So we've got the log of 2 plus x times the log of 6 is equal to, and our exponent is two terms, so again contain those two terms in brackets, so we know that they are both being multiplied by the log of 12. Okay, from here we'll expand the right-hand side. So the left is unchanged in this step. So we got the log of 2 plus x times the log of 6 is equal to, now we're going to get x log 12 plus log 12. Okay, anything containing an x to one side, anything not containing an x to the other side. Next step here, we've got x log 6 minus x log 12 is equal to log 12 minus log 2. The two terms on the left-hand side of the equation both contain an x, so let's factor that x out as a GCF. That leaves us with the log of 6 minus the log of 12. And so x is going to be equal to, as an exact value, the log of 12 minus the log of 2 divided by the log of 6 minus the log of 12. And we'll leave it like that. And the last one for today, we've got 3 times 2 to the x is equal to 12. This one is a little bit more straightforward. We can start by dividing both sides of the equation by 3. That leaves us with 2 to the x is equal to 4. 2 to the power of what equals 4? Well, x is equal to 2. And that's it.